Hello all, in this tutorial we are going to deal with exponents. In the GMAT test we do encounter questions based on exponents. So let us take a look at the basic properties of exponents and their applications. The first and foremost thing that comes to our mind is when we hear this word exponent, what is an exponent? An exponent of a number says how many times to use the number in a multiplication. Here a is multiplied n times, which can also be represented as a power n. Any exponent will have two parts, the base and the index. Here the base is a and the index is n. Let's take one example. 2 into 2 into 2 into 2. So here 2 has been multiplied 4 times, which can also be represented as 2 power 4, where 2 is the base, 4 is the index. Let's take one more example, 8 into 8. Here 8 is multiplied 2 times, which can also be written as 8 power 2, where 8 is the base, 2 is the index. It's time for us to concentrate on properties of exponents. So let's take a look at the first property of exponents. When there is a product of the same base raised to different powers, we can add up their powers. Here a power p into a power q can be written as a power p plus q. So let's see how this works. Let's take an example. 2 power 3 into 2 power 2 is equal to 2 power 3 plus 2, which can also be written as 2 power 5, that is equal to 32. Let's move on to the next property. When we are dividing the same base raised to different powers, we can subtract their powers. So we can say a power p by a power q is equal to a power p minus q. Let's take an example. 2 power 3 by 2 power 2 can also be written as 2 power 3 minus 2, which gives us 2 power 1, which is equal to 2. Hope this is clear. Let's move on to the next property. Let's move on to the next property. Whenever you see a product in the index, you can multiply those powers. So we can write a power p whole power q as a power p into q, or a power q into p. Let's take one example. 2 power 3 whole power 2 can also be written as 2 power 6, that can be in turn written as 2 power 2 whole power 3. Alright, let's move on to the next slide. On the GMAT test, usually students misconceptualize that a power m whole power n is equal to a power m power n, which is incorrect. A power m whole power n is equal to a power m into n. Let us take an example. 2 power 2 whole power 3 can also be written as 2 power 6, and 2 power 2 power 3 can also be written as 2 power 8, where 2 power 6 is not equal to 2 power 8. Therefore, a power m whole power n is not equal to a power m power n. Let us see how the questions are going to appear on the GMAT test based on these properties of exponents. Here in this question, if 2 power x into 2 power y is equal to 8 and 9 power x into 3 power y is equal to 81, then x comma y is equal to. Now, based on the first property of exponents, when we have same base raised to different powers, we add up their powers. So here 2 power x into 2 power y is equal to 8 can also be written as 2 power x plus y is equal to 2 power 3. When you have the same basis on either side of an equation, their powers can be equated. So here x plus y is equal to 3. Coming to 9 power x into 3 power y is equal to 81. 9 can also be written as 3 square. So 3 square whole power x into 3 power y is equal to 81. Based on the third property of exponents, when you have product in the index, you can multiply the powers. So here 3 power 2x into 3 power y will be equal to 81. So when you have the same basis raised to different powers, we can add up their powers. So 3 power 2x plus y is equal to 3 power 4. Here 2x plus y is equal to 4. As we all know, when we have same basis on the either side of an equation, we can equate their powers. We have two simultaneous equations now. X plus y is equal to 3 and 2x plus y is equal to 4. Once after we solve these two equations, we get x is equal to 1 and y is equal to 2. So the correct answer to this question is answer choice A. We do have some more properties of exponents. So let's take a look at the next property, which says when you have different bases raised to same powers, we can multiply the bases. Here a power p into b power p can also be written as a into b whole power p. So let's take one example. 2 power 2 into 3 power 2 can also be written as 2 into 3 whole power 2. In turn, it is going to be 6 power 2, which gives you 36. In the previous property, we did see we multiplied different bases raised to the same power. In this property, we are going to divide different bases raised to the same power. Let's see what will be the result. When you have a power p by b power p, you can also write that as a by b whole power p. So let's take one example here. 2 power 3 by 3 power 3 can also be written as 2 by 3 whole power 3. So far we dealt with positive exponents. In this property we are going to deal with negative exponents. So if you have a power minus p, then it can also be written as 1 by a power p, or it can also be written as 1 by a whole power p. For example, 2 power minus 3 can also be written as 1 by 2 power 3, which is nothing but 1 by 2 whole power 3. Before we try understanding this property, let's take one small example. Root of a can also be written as a power 1 by 2. Similarly, nth root of a is equal to a power 1 by n. We have some more properties here. 1 raised to any power will be equal to 1. For example, 1 power minus 3 is also equal to 1. When a negative integer is raised to odd power, the result is always negative. For example, minus 2 power 3 is equal to minus 8, which is negative. A negative integer raised to even power is always positive. For example, minus 2 power 2 is equal to 4, which is positive. Any number raised to 0 will give you a result equal to 1. For example, 5 power 0 is equal to 1. Let's take one more example here. Minus 3 power 0 is also equal to 1. Let's see on the GMAT how you'll be tested based on these properties. Find the value of 1 by 2 whole to the power of minus 3 into 1 by 4 whole to the power of minus 2 into 1 by 16 whole to the power of minus 1. Here 4 can be written as 2 square and 16 can be written as 2 power 4. So let's try simplifying the given equation. 1 by 2 whole power minus 3 can also be written as 1 by 2 power minus 3. 1 by 4 whole power minus 2 can also be written as 1 by 2 square whole power minus 2. 1 by 16 whole power minus 1 can also be written as 1 by 2 power 4 whole power minus 1. 1 by 2 power minus 3 into 1 by 2 power minus 4. Here we can multiply 2 into minus 2 into 1 by 2 power 4 into minus 1, that will give you minus 4. So when you have 1 by 2 power minus 3, that can also be written as 2 power 3 into 2 power 4 into 2 power 4. When you have the same base raised to different powers, we can add up their powers. So here it is 2 power 3 plus 4 plus 4, which will give you 11. So the final answer to this question is 2 power 11. It's time for us to take some more questions for practice. Let's take a look at this question. If m power minus 1 is equal to minus 1 by 3, then m power minus 2 is equal to. Now let's recall that property. A power minus n can also be written as 1 by a power n. So in this question we have m power minus 1 is equal to minus 1 by 3, which can also be written as 1 by m is equal to minus 1 by 3. If we take reciprocal on both the sides, we get m is equal to minus 3. However, in this question we are asked to find the value of m power minus 2. So in m power minus 2, in place of m, we can replace minus m by minus 3. So it becomes minus 3 power minus 2. Based on the property of a power minus n is equal to 1 by a power n, this can also be written as 1 by minus 3 power 2, which in turn gives us 1 by 9. So the correct answer to this question is answer choice D. Let us see how the questions are going to appear based on negative exponents on the GMAT. Which of the following is equal to 10 power minus of minus 3 whole square? So here 10 power minus of minus 3 whole square can also be written as 10 power minus 9. Let's recall one property of exponent which says a power minus n is equal to 1 by a power n. So 10 power minus 9 can also be written as 1 by 10 power 9. So the correct answer to this question is answer choice A. If you just look at your answer choices, answer choice E is 10 power 9. Most of the students might choose this answer choice E. So here answer choice E is a trap answer. Please pay attention to these details. Coming to the next property. Bases are equal when exponents are equal, which can also be written as x power a is equal to y power a implies x is equal to y. To understand this property better, let's take one example. If x square into x power 4 is equal to 2 power 6, then x is equal to. Here we have x square into x power 4. When we have the same base raised to different powers, we add up their powers. So x square into x power 4 can also be written as x power 2 plus 4, and that is equal to 2 power 6. X power 6 is equal to 2 power 6. So here we have the same exponents on either side of the equation, which in turn implies x is equal to 2. So the value of x is 2. We have a similar property which says exponents are equal when bases are equal. So let's take one example. 3 power 4 into 3 power 5 is equal to 3 power x. So when we have same bases raised to different powers, we add up their powers. So 3 power 4 into 3 power 5 can also be written as 3 power 4 plus 5, that is equal to 3 power x. As we have the same bases on the either side of the equation, I can say x is equal to 9. We hope this video tutorial on exponents was informative. Don't forget to watch the other video tutorials that are required to ace the GMAT. Thank you.